Hello everyone, welcome to your channel Data Science Studio, and today we are going to start with day 20 of Python programming for data science. So let's get started. In today's session we are going to start with a new library which is Matplotlib, and we will be talking about some of the functionalities which we can do by data analysis using visualization techniques. So Matplotlib is one of the most important popular Python data visualization library, and it is extensively used in data analysis and exploration, and most of the other visualization libraries like Seaborn are built on top of it. So if you have to install the Matplotlib, you can do it from the Jupyter using pip install, or you can do from the command prompt as well using the pip installer. So let's first import all the libraries. And in this particular session we'll be using tips dataset, which is a freely available dataset in the Seaborn library. And the tip dataset actually represents the tipping data, where one person recorded information about each tip he received over a period of few months. So this is our tips data. So here we have close to 7 variables and 244 observations, and some of the variables are float, some of the variables are category, and we will see that what kind of visualization techniques we can imply. So here tip is your target variable, or we can say dependent variable, which we would want to predict or foresee from other variables as well. So Matplot graphs the data on the figure object. So the first thing which we have to understand, there are two things, one is figure and one is axis. So Matplot graphs the data on figure object, each of which can contain one or more axes, and the plot is actually done on the axis. So axis is the area where the points can be specified in terms of xy coordinates. So here we are creating the figure object. So you can see it is with 0 axis, and then we are creating the subplot. So here you can see that it is a single axis. Within a figure you can have multiple axes as well. So here for example we are having 2 rows. So 2 comma 3 means 2 rows and 3 columns. So this is 2 rows and 3 columns. Now there are different plot styles available in Matplotlib, something like classic, solarize, BMH, dark background, 538 ggplot, and there are many more. We will see the implementation of those. There are two ways in which you can use Matplotlib library. One is by using the explicitly creating the figure and axis object, which we will be seeing, or by using the pyplot object of the Matplotlib library. And in terms of layout, there are two kinds of layout in Matplotlib. One is constraint layout, one is tight layout. The objective of both of these layouts is to adjust your subplots properties like legends, color bars, labels, everything, so that they fit in a figure window. So it is not, the figure is not scattered across, it will be in a within a window. So we'll see that how that works. So first plot we are going to see is the scatter plot. So scatter plot is basically used to visualize the relationship between two continuous variables, whether it is positive, negative or neutral. And the scatter plot is also used in is also helpful in identifying the outliers as well. So let's run this. So here you can see that I am using the style as classic. So this is the classic format, and layout is constrained. So if you see, everything is within this boundary. Your label, your title, everything, legend, everything is in the figure object. So I am creating a figure object using subplot method, and the object size is 8 by 4. And using the scatter method within the axis, you can plot. So tip is x-axis, total bill is y-axis, and there are 244 observations in our dataset we have seen. So we have to give a numpy array to plot each color differently. So if you see, each color is unique in its own based on this numpy array which you are passing as a color, s equal to 100, which is the size of this bubble, and you have to pass your data frame, and you can set the x label, you can set the y label, you can set the title. So title is the scatter plot, and you can set the legend as well. And you can, to show the graph, you can show plt.show. When you run this, you can see the output like this. Is very colorful output. You can play around with different styles which we have seen earlier as well. The same thing we are trying to do with a grayscale. So if you see, the grayscale looks like this. So this is the grayscale image where all the observations, all the circles are actually in black and white. Same format. This is how you do the scatter plot, and the scatter plot is the first thing which you do in any kind of exploratory data analysis to understand the pattern between the two continuous variables. And if you want to check the correlation using any formula, you can use the correlation method to check the correlation between two variables. So here we can see the correlation is slightly moderately high positive, so which is 0.68. Next topic which we are going to see is histogram. So a histogram is used to display grouped frequency distribution for continuous data, and it also shows spread and shape of the data and helps in analyzing the patterns. So here we are trying to do the histogram for the total bill variable. So let's see that. So this is the histogram, you can see in the figure. So some properties like style, you know, this is the dark background style, layout is constrained, and plot size is 8/6, and you are plotting the total bill variable, and you are splitting that total bill variable into 10 bins. So this 10 bins is equal to these 10 bars. These are equally split values between the maximum and minimum. So all the values will be equally splitted into 10 parts, and you are setting the label, and you can set the font size as well. You can set the Y label, you can set the title as well, and show the plot. You can change the color as well. For example, if you want something like blue, it will change it to blue. Like this, you can change the colors and play around the visualization as well. So this shows the data is slightly normally distributed with some skewness on the right side, right tail. We will be doing learning lot of transformation techniques in our EDA session, but for now you can assume that this data is slightly normally distributed, and all your continuous data must be normally distributed if you are doing any analysis like regression or logistic regression. Now bar plot. So the bar plot is actually used to show the distribution of data for a categorical variable. So let's say that I have this categorical variable. First of all, you have to process your data in a certain format to show the counts. So I'll go step by step. So first style, you know how to do it, then the figure size and layout, and then labels. Label means what is the x-axis you want to give. So my label is, I want to understand at day level what is the total count of customers visiting the restaurant, and here I am specifying colors as a list, and this is the important line. So your tips data day dot unique. So this unique will actually give you the labels, and height of the bar will be value counts. So tips data day dot value count. So for each day, what is the total number of observations for that day? That is actually the height of your bar. So you can say that close to 85 people have visited on Sunday, and then followed by Saturday, Thursday and Friday. So Thursday also people have visited more compared to Friday. And you can pass the color parameter. Alpha is actually the transparency. The more the value of alpha, the darker the color will be. And you can specify the labels as well. You can specify the X label, Y label, title, and you can do the show the plot. You can change the title, color, anything. You can play around with all the colors. You can do like this. Now this is bar plot of a single variable. Now let's say within Sunday I want to identify how many males, how many females have visited, and based on gender I want to split it. So for that we can use two kind of charts. One is called as grouped bar chart, one is called as stacked bar plot. So we'll see first group bar chart. So here you can see that what is happening is the same data is splitted into two parts. One is for gender wise male and one is for female. So here you can see that earlier we were doing the count at day level. Here we are actually filtering out the data first only for female and only for male, and then we are doing the count day wise by grouping it. And then your labels will be will be the days. So these two lines are important. So I am creating the figure object. So my first rectangle will be actually the bar plot of the gen M, which is the gender male, and the second bar will be gender female, and you have the labels and colors as well. Now you can set the Y label, you can set the X label, you can set the title as well, and this X text is actually to specify the labels. So for each value of X which is over here, I am specifying these labels. So you can set the X-Tix. X-Tix is a parameter, set underscore X-Tix is a method within the axis object to set your labels of the axis, and you can set the labels of Y-axis using Y-Tix as well. You can set the legend. You can set the location as upper left, there is the upper right, bottom, things like that. And then you are plotting this function, you will get like this. So if you want to get your bar plot splitted by multiple categories, you can use the grouped bar plot. Similar ways you can use the stacked bar plot. So in a stacked bar plot, each bar is divided into multiple bars to represent more than one column. So here you can see that. Here what we are doing, same count, we are filtering out the data for gender male and female, and then what we are doing is, instead of creating two bars, what we are doing, we are actually specifying the bottom bar as male and the upper bar will be female. So if you see, this bottom bar is actually specifying the data observations for the male, and the upper bar is specifying the observations for the female. So if you see, the total bar is split into two colors. So stacked bar plot is also more visually appealing. You can use the stacked bar plot, you can play around with the labels, colors, font size, everything you can adjust. So bar plot is very important if you want to understand the representation of the multiple categories in your data set. Next plot is called as pie plot. So the pie chart represents data in the circular graph format, and the slices of the pie chart shows the relative size of the data. So the bigger the slice size, the bigger is the percentage with which that it represents the data. So I am using the style as 538, and you can use the labels. So label is the days, different days of the week when people have visited the restaurant, and your pie data is again the count, because you are representing the categorical data. This explode functionality is important, because if you want to explode any pie out of the whole pie chart, so here I am exploding the second pie. So this is first pie, Sunday is first pie, Saturday is second pie. So I am exploding the Saturday out of the whole pie chart. So here I am setting the figure object, and here you can see that we are doing all the different properties. So explode you know, labels you know, auto percentage, which means that we are making this labels up to 1 decimal place. Shadow equal to true means you are seeing some shadow at the corners, that is shadow. And start angle equal to 90, which means it will start from the 90 angle, which is like this. And text props is an important metric. So text props shows that what is the font size of your labels and what is the font color. You can change the font size or font color. Let's say if you want to change it to blue, you can change it to blue as well, like this. And ax.axis equal means that you want to give the shape of the circle. So if you don't specify this, it might take a little bit shape of a sphere or oval. So to avoid that, we give this as the parameter. You can set the title and you can set the title color as well. So all this, and now if you change it back to black, this is your bar chart. Next very important plot is box plot. So the box plot is used to represent a continuous variable as a 5-number summary, which is minimum, Q1, Q2, Q3 and max, and it is used to highlight outliers present in the variable. So let's see that this is our box plot. So this yellow color labels which you are seeing is actually annotation. So we are actually x is equal to 1.2. So this bar plot is located at value of 1, so 1.2 will be slightly right of it, and y will be actually the minimum, quantile, 25th quantile, median, 75th quantile, and max. So there are 2 points to be noted. So 1 max is this line. So this min is actually the minimum value in the data set excluding the outliers, and this line over here is the maximum value in the data set excluding the outliers. What you see maximum over here is the overall maximum value of the data set, but this line is maximum excluding outliers. So all these dots which you are seeing is actually outliers in your data set, and there are various techniques by which you can handle the outliers. We'll be seeing in our EDA session. Now if you see, we have the Q3 and Q1 and median. So Q1 is that data point below which 25% of your data lies. Median is that data point which splits your data into 2 halves, and Q3 is that data point below which 75% of your data lies. So this box plot is very important for continuous variables, because you would want to understand what is the amount of outliers which is present in your continuous variable. So these graphs we are kind of generic graphs, and we do for any exploratory data analysis, and you should be very clear in terms of how to play around with the formatting, font, color, style, and layout. So this session will give you all those understanding. So next session we will be talking about visualization using Seaborn package, which is built on top of Matplotlib, and it has various other interactive functionalities to make graphs. So please subscribe, like, and comment your channel, and stay tuned and stay connected. Thank you.